Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss about 23 ITT 301 Microcontroller and Embedded System subject under Unit 4, Design and Integration of Embedded System for the topic Introduction to Embedded Systems. Now we will move on to the video. What is embedded systems? Embedded system is a computational system that is developed based on an integration of both hardware and software in order to perform a given task. It can be said as a dedicated computer system has been developed for some particular reason. But it is not our traditional computer system or general purpose computers. These are the embedded systems that may work independently or attached to a larger system to work on a few specific functions. This embedded system can work without human intervention or with little human intervention. Now we will discuss this topic based on a design thinking approach. The design thinking approach consists of 5 phases. One is empathize, define, ideate, prototype and testing. Now I will discuss the first phase of design thinking called empathize. Why embedded system? The central node is the user needs and context. Branches are everyday users like smartphones, and smart watches. Industry are robotics and automotives. Healthcare are pacemakers, monitoring devices, and the users are demand for speed, efficiency, and low power. The sub-branches are real-world challenges is equal to automation, connectivity, and safety. So this figures also shows how the design thinking empathize are implemented in embedded system field. Next, embedded system based on stakeholder. So who are the benefits? The end users are student, professional and consumers. Manufacturers are electronics and companies. Developers are engineers, programmers, and the government defenses are used in the critical systems. Next, the define phase, that is the problem space. Their central node are challenges in system design like power efficiency, real-time operation, compactness, cost constraints, and scalability and upgradability. So these are also shown in the figure. These are the various problems that are defined when you have to decide a good embedded system. Next, what is an embedded system? We have to give a proper definition. That is, it is the hardware and the software integration process, or it works on a dedication function. For example, if it is a washing machine, then the purpose is only worked on a washing clothes. Then if it is a chocolate vending machine, then their purpose is only provided chocolate. Next, runs in real time, resource constraints that are considered for define. The next is the ideate part. Ideate part means we have to give a good solutions for this problem. That is, ideate means we have to provide the core components in the embedded system. Here, microcontroller or processors are the core components. Second, the memory. Memory are ROM, RAM, and flash memory. Then input-output interfaces are sensors is the input devices, and actuators is the output devices. The next, communication. The communications are connected through UART, Universal Asynchronous Receiver Transmitter. Then integrator communication. Then SPI, serial port information. Then CAD accredited network, and the software, some of the softwares that are used are RTOS or firmware. Next, the important part is the prototype. Wait, I will move this photo to somewhere. Prototype is based on architecture models. So this is given the 3 architecture model. One is the von Neumann architecture, which is used the shared bus in their architecture size. Second one is the Harvard architecture, which is a separate buses are there. Then the third one is the RISC-CISC architecture, where both are based on instruction efficiency. So these are discussed in this left-hand side. There are 3 branches are there. One is the von Neumann, that is the shared bus architecture. Second one is the Harvard, that is separate instruction and data buses are used. Third one is the RISC-CISC, instruction based on efficiency. The next, this is the last part, that is the fourth part, prototype. That is, we have to construct how the embedded system is classified. Embedded system example is smart home light controller. Here the input is the motion sensor. Then processing are done to using a PIC microcontroller or Arduino microcontroller or ARM microcontroller. Then the output is the LED light or Wi-Fi notification. The software which is used are a simple firmware to toggle lights. The next phase is the testing part, that is evaluation metrics. So the central node are the testing parameters. There are various testing parameters are there. One is the reliability, that is runs without crash. Second one is the accuracy, correct sensor readings. Third is the efficiency, low power consumption. Fourth is the safety, that is no malfunction is in critical use. Then the last one is the cost wise, that is affordable for users. So the next part is the continuous and user friendly improvement. That is, we have to get a feedback and iteration from the users. The branches are prototype, test, improve. User feedback are ease of use and performance issues. Iterative design are to remove bugs fixing and optimization. Then scaling factors are from prototype to mass production. So these are some examples of how the embedded system are used. Mainly the embedded systems are used in manufacturing equipment, domestic appliances, audio-visual equipment, gaming consoles, telecommunication equipment, medical devices, cars and vehicles, and the final is the motion sensor. Also, this embedded system are used in traffic management, security system, printers, microwave ovens, ultrasound machines, audio systems, televisions, and fax machine. So now in this YouTube video, I discussed how the embedded system is working based on design thinking process, and I also discussed some of important applications of embedded system. Thank you for watching my video. Next YouTube video, I will come with a new topic. Thank you all.